science lesson. And as we discuss, you observe or you watch the series of the topics from Boris B TV at YouTube and subscribe. There are a lot of lessons which are being treated there, so far as integrated science lessons are concerned. Today we are going to look at another interested integrated science topic, which is matter, the nature of matter. And when we talk of matter, matter is anything that has mass and can occupy space. So, anything that you can find in this universe which has mass and can occupy space, or which has mass and volume, can be considered as matter. So there are several matters that you can talk of on this topic. Some are solid, some are liquid, some are gases. That is when we go to the state of matter. Good. And with matter, we have atoms, we have the molecules, and we have the ions. All these coming together to form the particulate nature of matter. So the particulate nature of matter is made up of the atoms, the molecules, and the ions. So let's write matter, nature of matter. Or we can simply say matter. As I told you, matter can be defined as anything that has mass and occupies space. The space which is occupied by matter can also say volume. The space occupied by matter can be said to be the volume. Matter is anything that has mass and occupies space or volume. That's it. So, when we talk of the mass, it means the quantity of the substance that we are talking about. How many particles are forming that substance we are talking about? And that is what we mean by mass. How many particles coming together to form that substance? So let's talk of mass. The number of particles forming the substance or the matter. Or the quantity. Good. So that is the mass. And when we talk of the space which the matter is occupying, which we can say is the volume, then we are talking of how much area can that matter occupies. For instance, let's take this and see. This duster from the board, we can see it has occupied some amount of space on the board. And with this space, you can calculate the volume from the length times breadth times height. Then you get the volume. So the volume that the matter has occupied is what we mean by the space. Good. So the volume or the space is the volume occupied by the matter. Good. The space occupied is the same as the volume which the matter has taken. Let's talk about the particulate nature of the matter. Matter is made up of particles, and that's what we term about the particulate nature of the matter. Matter is made up of particles, several particles, which they are discrete. Good. So these particles include atoms, molecules, and ions. We will look at how the atoms are, how the molecules are, and how the ions are, and how at least they are different from one another. So let's talk of particulate nature of matter. Good. So we have an atom. Or let's say atoms. Good. These are the particulate nature of the matter. We'll talk about each one of them with some simple diagram for your understanding. Atom is defined as the smallest of particle of an element, is the basic unit of matter, and we can say atom is the smallest particle of an element. Good. The smallest particle of an element. That can take part in a chemical reaction and maintains its chemical properties. It can take part in a chemical reaction and maintain its chemical properties. Let's look at some simple structure of atom. Good. For instance, if this is the simple model of sodium atom, I have the several particles that come together to form these sodium atoms have similar properties. They are alike. Let's look at, for instance, maybe gold, atoms of gold, or any of the element, let's say aluminium. Good. If this is the structure of aluminium, let's see. It could be that the particles coming together to form that aluminium atom are similar. They could be so big as this, as that, as this. Good. And if you look at the properties or the structure of the particles forming the aluminium atom, you can see they are similar in structure and in shape. And that of sodium also are similar in structure and shape. So, any element or any atom have similar properties to that element or to that particular matter we are talking about. Let's look at molecule. Good. When we talk of molecule, we are talking of combination of two or more elements or atoms coming together. Two or more elements coming together. The two elements which are coming together could be the same element, nitrogen and nitrogen, so that you get nitrogen molecule. It could be hydrogen and oxygen, like water, H2O, two atoms of hydrogen, one atom of oxygen. Then you get a molecule of water. So when we talk of molecule, we are talking of two elements which are chemically joined together. Could be two or more. And the two or more elements could be the same element or could be different elements, but it are joined chemically together. Good. Molecules. A molecule. A molecule is formed when two or more elements are joined together chemically. It is a chemical combination. Molecules are joined chemically, so it is a chemical combination in a fixed ratio. Can add it that in a fixed ratio. Good. The elements which are coming together to form the molecules are called the molecules of element. And this one means these are the same elements coming together to form the molecules of element. We have molecules of compound. That means the elements are different. Okay, so the combination or the joining together of the element could be the same element or different element, and it does that in a fixed ratio. Good. So sometimes you can choose to end here that it is a chemical combination of two or more elements. In a fixed ratio could be also added. So you can drop or you can bring everything. When the elements are the same, like nitrogen and nitrogen, like hydrogen and hydrogen, coming together, we call it molecule of element. This is when the same or similar atoms have joined together to form the molecule. Let's continue there. So as we have come to continue there, before I clean it, matter is anything that has mass and occupies space. The space which is occupied by the matter is what we call volume. So mass is the number or the quantity of particles forming the substance. So the space occupied is the volume. Okay. Matter is made up of particles, that's discrete particles. And so we have the particulate nature of matter, which is made up of the atoms, the molecules, and the ions. So, to continue the molecule of element, this is when similar elements or atoms Good. For instance, we can have nitrogen molecule. Good. Nitrogen molecule means nitrogen therefore we get nitrogen molecule or nitrogen gas. Good. So that's it. We can also have that of chlorine. When two chlorine also come together, you can get the same thing. Or hydrogen gas. hydrogen molecule. That is hydrogen plus hydrogen, you get your hydrogen molecule. Good. Let's go to, so this one is a molecule of element. We have molecule of compound. Let's go to molecule of compound. Molecule of compound. So let's see a molecule of compound. Molecule of compound, we are talking of two different or three different atoms coming together in a fixed ratio to form a different substance or to form a compound, which the properties of that compound will be different from the individual properties forming the compound. For instance, water has hydrogen and oxygen. So when the oxygen and the hydrogen come together, they form water. And which water has different property from hydrogen and also has different property from oxygen. So let's check that one too. Molecule of compound is made up of different atoms joining chemically in a fixed ratio. Good. For instance, water. Example, water molecule. Good. If you look at water molecule, you have two different elements, hydrogen and oxygen. Unlike the molecule of element, which is nitrogen, nitrogen, hydrogen, hydrogen. The same element coming together to form different property or to have different property. But this one, hydrogen and oxygen. Two atoms of hydrogen, one atom of oxygen. And hydrogen has different properties. Oxygen has different properties. But when they combine, they have a different properties from that of hydrogen and oxygen. And this one, if you want to compare, you have properties of water, which are different from properties of hydrogen and oxygen. Let's have a simple model to see how that one will be. So we can have one oxygen bonded by two atoms of hydrogen. So it could be like this. Good. So this could be a simple structure or a model of water molecule. Okay, that's H2O. Good. So, with this, we understand that atoms atom, the particles forming that atom are similar, and they are different from different atoms. For instance, sodium atom have similar properties forming that sodium atom, but aluminium atom also has its own similar properties. When two atoms come together, they form a molecule. And the molecules, if the elements or the atoms are the same, then we have molecule of elements. That means that molecule is formed by the same element. Like we have in N2, that's nitrogen molecule or nitrogen gas, hydrogen gas, which is hydrogen plus hydrogen. Then, if you want to talk about molecule of compound, it means that compound is formed from atoms of different elements. Atoms of different elements. Let's look at ions. An ion. The particulate nature of them matter, the atoms, the molecules, and the ions. So let's talk of the ions. An ion is formed when an atom or an element loses or gains an electron. You have some simple diagrams to explain this. So, atoms are made up of protons, neutrons, and electrons moving around the shells. And anytime the atom loses electrons, it means the protons outweigh that of the electrons, and that atoms become positively charged. So we call it cation. But when the atom gains electrons to itself, the electrons outweigh that of the protons, and it becomes negatively charged, and we call it anions. So, if you are talking of an ion is formed when the atom loses or gains electrons. Good. Ion. Chlorine, ion. Oxygen, ion. Good. These are some examples of ions we are talking about. Sodium ion, aluminium ion, chlorine ion, oxygen ion. Some have positive charge, some have negative charge. And we have defined ion simply as an ion is a charged atom. This is what we mean by charge. A charge of positive or a charge of negative. So anytime you see an atom written with a charge at the superscript, it means that atom is an ion. It has a charge. We will see Why this has positive charge, but this has negative charge? So when you go back, an ion is formed when an atom loses or gains electrons. When the atom loses electrons, it becomes positive charge. We have told you that the number of protons is equal to the number of electrons. The electrons are equal to the protons. So when it loses electrons, it means the protons are becoming more. You get positive charge. And when it gains electrons, it means it has increased its electrons and it is now more than the protons, so it becomes negative charge. That is where we are going to get anions and cations. Positive ions, negative ions. So let's see some simple example of cation and anion. Cations. Let's define it. Cations are ions which are positively charged, meaning they have lost electrons. Cations, these are positively charged atoms. Before they can become positively charged atoms, it means they have lost some electrons. This means that the atom has lost some electrons. Either electron or electrons. Let's look at some scenario. For instance, let's take sodium atom and see how it becomes positive charge. Sodium has atomic number of 11 from the first 20 elements. So let's see how it behaves. The electronic configuration. Then we have sodium, positive, aluminium, 3+, as our cation, have chlorine, oxygen, 2-. As our anions. Now we are talking of sodium. If we draw the electronic configuration of sodium atom, we have the central nucleus, the first shell, which is K shell, second shell, which is the L shell. So, the first shell of the sodium atom will take 2 of the electrons. The second shell will take 8. Making it 10. But sodium has 11 electrons. Atomic number 11 means it has 11 electrons and 11 protons. Anytime you mention of the atomic number of an element, you have mentioned the proton number and you have mentioned the electron number. So, when we say sodium has atomic number of 11, it means protons are 11, electrons are 11. So it means it remains 1. Now it has 11 electrons moving around the shells. So we have the K share, L share, and M share. So the electronic configuration for sodium atom, if you have sodium and you have K, L, M, then we have 2, 8, 1 as the electronic configuration of sodium atom. And from the stability theory of an element, this means this last share is not stable. Only 1 electron at the last share, of which the last share can have a maximum of 8 electrons. So only 1 share on that, only 1 electron on the share makes it unstable. So to make it stable, initially aluminum atom. Let's see how the ion will be formed. The aluminum has atomic number of 13. Aluminum has atomic number of 13. So, in drawing the electronic configuration for aluminum, we will have 3 of the shells, which the first shell will take 2. The second shell will take 8, making it 10. The last shell will take 2, 3. And these 3, from electronic configuration theory, it is making the last shell unstable. So, it will be given out to make the last 2 very stable. So let's see, it will lose 3 electrons. If the electrons are not up to 4, it's not convenient to maintain it. But electrons if the electrons at the last share are 1, 2, or 3, it is easy to give it out. But if the electrons at the last share are 4, 5, 6, 7, it's better you gain 1 to 8. When it is 8, it is stable. So let's see how the aluminum will lose 3 electrons. Loss of 3 electrons. So when it loses 3 electrons, we are going to have 2 of the shells. Two electrons in the first shell, and 8 electrons at the second shell, making it 10. So now, aluminum has lost 3 electrons, and it is now called aluminum ion. Now, let's see the mathematical. So to continue, the first shell has taken 2 electrons, second has taken 8 electrons, and the third shell has taken 3 electrons. So the K, L, M shell. Now if you come to the electronic configuration of this one, it is K, L, M. For the aluminum, we have the first one to be 2. We have the second one to be 8, and the third one to be 3. This is electronic configuration for the aluminum. But let's check of that aluminum ion. Now we have only 2 shells. So aluminum ion has only 2 shells. That is KL, KL, KL. Kl. So 2, 8. 3 is lost. And we have said that anytime you say aluminium has atomic number of 13, you have mentioned the number of protons, that the protons are 13. And you have mentioned the number of electrons, that they are also 13. Virtue of saying the atomic number is 13 means the proton number is 13, electron number is 13. Keep it. So, if the proton aluminium has 13 atomic number, it means proton is 13, positive. Electron is 13, negative. Now let's see. Loss of 3 electrons. So 1, 2, 8, 10. And the 3, 1, 2, 3 is lost. So we have 1 share, 2 share, 1 share, 2 share. The third share having the 3 electrons is lost. So it means 3 of the electrons will be taken from the electrons we have here. So minus 3. So 3 electrons is taken away. Meaning we are going to have protons of plus 13, electrons of minus 10. Meaning 3 electrons has been taken away from the electrons. So the total is going to be plus 3. And that is the charge for aluminium. Good. So, difference of 3. So you have aluminium as 3 plus. That's how you get the aluminium ion. So you have to take note that an ion is formed when an atom loses or gains electrons. So these ones, they are all losing electrons. And as they are losing electrons, the negative is coming down, the positive is going up. And that is what we call cations. Cations. You go to anions, where they will gain electrons. So it means you are going to have more electrons than the protons. So the charges are going to be negative charge, as we saw in chlorine ion and oxygen ion. We will continue from there. Now, we finish with that of cations. We have to go to that of anions. So if we talk of anion, it is an atom with a charge, and the charge is negative charge. It means it is a negatively charged atom, as we have in chlorine and oxygen. Good. From the definition of an ion is a charged atom. That means the atom has a charge, either positive charge or negative charge. And how do they get the charge? They get the charge when they lose or they gain electron. Good. So, if they lose electrons, it means the electrons are going down and the protons will be excess. And that you get the positive charge, that is cation. But in anion, they gain more electrons, meaning the electrons overcomes the proton charge, and that is anion. So let's take the definition of an anion. Good. A negatively charged atom. Example: chlorine, ion, oxygen ion, good. They gain more electrons into their outermost shells, and that made the electrons negative charge powering or in excess to the proton's positive charge. So let's see how it is formed. Chlorine. Chlorine atom with atomic number 17 will have the first share at the central nucleus with the protons and neutrons. The first share having 2 electrons, second share having 8 electrons, totaling 10. And because it's 17, the last share will have 7 electrons. Good. This is 17. So chlorine KLM287. Good. For the atom to be stable, more stable, the last share, which is the M share, KLM share, supposed to gain 1 electron into itself, so that it will be 288. And that one will be, so let's see, if this one gains electron, it means it is going to be the central nucleus, first 2 electrons at the K share, 8 electrons at the L share, and gaining 1 electron, it means it is added to it to be 8. So now this has gained an electron, and we are going to have chlorine minus as KLM. So 288. Now the 7 electrons at the M share is now 8. That means gain of electron. And if you check the difference, protons of 17, which is positive, electrons of 17, which is negative, and if you are bringing in 1 electron, it means you are adding now another negative electron to it, and therefore you are going to get 18. So this one will be plus minus 1, and it's going to be minus 18. Therefore, the difference is going to be minus 1. Minus 1. When you compare the plus 17 and minus 18, the difference is minus 1. That's why we say minus 1. And we don't write 1 minus or minus 1. No. As soon as you write the symbol minus, it means it is 1. But if it is 2, you write the 2 minus, 3 minus, 4 minus. But when it is 1, you only write the charge. If it is positive, you write this, means positive 1. But if it is 2, 2 positive. Good. So chlorine minus means chlorine ion, and the net charge is 1. Good. Let's check, for instance, oxygen and see. An anion is a negatively charged atom. So let's see. Oxygen is also an anion. Oxygen has atomic number of 8. So Oxygen atomic number 8. To draw the electronic configuration, that means to show the number of electrons moving around the shells, let's put the structure of the atom down. That means the electronic configuration of atom, of oxygen. The center nucleus. This dot stands for the central nucleus. When you are drawing electronic configuration, the dots at the center stand for the nucleus. And the nucleus contains the protons and the neutrons, which the protons is positive charge and neutrons is neutral charge. So the center nucleus is very important in drawing of the structure. The first shell will take the 2 electrons. The second shell will take the 6 electrons. Good. But from the theory, K, L, M. This KL, only KL. M didn't come. First share K, second share L. The first share is supposed to take 2, the second share is supposed to take 8. But here we have only 6. To make it stable, we need the extra 2 to 8, so that you get your 2, 8, and this is the stable electronic configuration. So, because it has only 6, and the first has taken 2 and the second has taken 6, it means you need extra 2 to the last share, so that it will be 8, and it will be stable. And that is where it is going to gain. It is going to gain some electron. So gain electron. And definitely we are going to gain 2. We are going to gain 2 electrons. And if you are going to gain electrons, it means you are going to be an ion. And that's the definition. An ion is formed when an ion is formed when an atom, this is an. When an atom loses or gains electrons or electron. So this structure is going to gain electron. So when it gains 2 to itself, it is going to be first 2, then the other 2 will be here. Good. So we have gained 2 electrons. And this means the electrons are now more than the positive charge. Or the protons are plus 8, and electrons are negative 8. So now that it has gained extra 2 plus negative 2, it is going to be, electrons are going to be negative 10. And the difference will give you minus 2. Good. That's why we see oxygen 2 minus. And this one is a charged atom. So an ion is a charged atom. So this atom with charge means it is an ion. So when you see this oxygen, this is not having any charge. Aluminium atom, no charge. But as soon as you put aluminium 3 plus, it means it has a charge. As soon as you do this 2 minus, it has a charge. So any charged atom is an ion. And when the charge is positive, we call it cation. When the charge is negative, we call it anion. How are they formed? And that's what we see. We see here. By gaining electrons, you are becoming an anion. By losing electrons, you are becoming a cation. That is positive. So keep notice of how positive ion is formed, how negative ion is formed. We will look at state of matter. We have the solid, liquid, and gaseous state. All the matter or the particles or the substance we are talking about can be in a different state, either in solid state or liquid state or gaseous state. So we are going to look at change of state of matter. But before that, we have radicals, which include NH4 ions, OH negative. For instance, radicals. When we talk of radicals, they are atoms which have come together containing more than one different atoms. For instance, NH4 plus. This one is ammonium ion. It has two different elements, nitrogen and hydrogen. 4 atoms of hydrogen, 1 atom of nitrogen, combining to form the ammonium. And with the plus here, net charge of 1 positive, we call this radical. Let's see OH, the hydroxyls, minus, OH minus. These ones are also called radical. Two different elements, oxygen and hydrogen. So these are radicals. This is cation. That is cation, for example, aluminium 3 plus, sodium plus, then anion. Anion, that means chlorine, negative, oxygen 2 minus. Good. Radicals, the elements are different. They are compound, different. They are molecules, 2 different elements with a net charge, 2 different elements with a net charge. 1 element with a net charge, but the charge is positive, cation. 1 element with net charge, positive, cation. 1 element with net charge of negative, anion. 1 element with negative charge, anion. So that is cation, anion, and radicals. And now we can move to the state of matter. The state of matter.